All right, guys, let's look at lesson 2, which is the nature of energy. So first, what does that mean? We already talked about the wave nature of light, the fact that light travels in waves, but that doesn't explain what happens when your temperature increases. So Max Planck explained that it can be assumed that energy comes from packets called quanta. So quanta are little packets of energy. What he did is he went off of what Einstein said. So we've already talked about this when we talked about Einstein's article. So Einstein used this assumption to explain the photoelectric effect, that he concluded that energy is proportional to frequency. So E is energy is equal to, this is Planck's constant, and V is frequency, or nu is frequency. And H is equal to 6.626 times 10 to the minus 34th joules times seconds. So remember, he talked about this. So if you hit a metal surface with energy, it's going to emit electrons. Those electrons are going to create energy, and you can test that. So what does that mean? If you know the wavelength of light, then you can calculate the energy of the light, and we can use our equation that we learned in lesson 1, which is C equals lambda nu. So now we have H equals, or E equals H nu, and we can put them together where we can, if we know the wavelength of light, we can figure out how much energy it has. So E equals Hc over lambda. And this equation at the bottom is a combination of these two. So let's put these equations into practice. All right, guys, let's look at this example problem. Determine the energies of photons with a frequency of 4.5 times 10 to the 14th seconds. So you need your equation, which is E equals H nu. E is what we're solving for. H is Planck's constant, so 6.626 times 10 to the minus 34th. And then you plug in your frequency, which is 4.5 times 10 to the 14th. Plug that into your calculator, and you get 2.9817 times 10 to the minus 19th joules. Okay, let's look at the next problem. It says determine the energy of photons with a wavelength of 4.0 times 10 to the minus 7th. So first you have to plug in your E equals Hc over lambda, and then you get Planck's constant times the speed of light divided by your wavelength, and you get 4.97 times 10 to the minus 19th joules. These are just straight plug-in problems. All right, so let's look at a practice. Determine the energy of photons with a frequency of 5.5 times 10 to the 14th seconds. Pause the video, unpause when you're ready. Great, what did you come up with? You should have taken your equation E equals H nu and plugged in Planck's constant for H and your frequency for V, and plugged that in your calculator and got 3.64 times 10 to the minus 19th joules. All right, let's look at it to check your understanding. Remember, you need to have this complete in order to get credit for your homework. See you tomorrow.